I want to explain what software prototyping is before we get started with this video. A software prototype is a simulation of how the actual project will look, work, and feel and would not have an exact logic involved in the software development phase. Software development team members use it for designing user feedback and user testing, and they come in various levels of sophistication. Software prototyping refers to the process that starts by creating an idea, sketching it, and making it into a clickable prototype that mimics real software. The prototype can offer simulation for the entire software or mobile application as per the requirement of the user. Prototyping in software development is just like a scale-building model that is utilized in designing architecture. In that case, creating a sophisticated prototype is necessary as it enables making a complex project look easy. It enables the customers to see the exact plan of the software development, and by having a look at that, they can provide feedback to the software designer. The best part of a software prototype is that it is cheaper and easier as changes can be made in the middle of the software development process instead of making changes after its completion. Therefore, while creating software, an engineer prefers to develop an initial prototype that he or she can use to gather feedback from the project owner. When it comes to creating software for the client from the very beginning, the process starts from the initial planning phase. The software development team comes with an application idea that is very well thought out so that the implementation can be easy. The team follows the software development lifecycle (SDLC) process to have a clear and straightforward approach among the team members. This process starts with developers gathering all the software-related information from the client and understanding the client's requirements. The next step is to start the designing process. It offers details of what the software's end-user interface will look like. After that comes the actual coding part of the system. It is the most lengthy part of the software development life cycle. Later, the team checks the code and fixes the bugs if there are any. The final step to do is to launch it. And in this entire process, prototyping software can help by cutting down the overhead costs. Software prototypes help software developers visualize the final product before the software development company starts investing resources into it. It is not a replica of the software, but it is a quick mock-up that offers a rough idea about the system's functioning and appearance to the software engineering team. The team can see the prototype and can decide whether the idea of this project is worth the investment or not. Besides this, as prototypes offer a clear idea about the system, the result can be as user-friendly as possible. A prototype enables developers and designers to show an understanding of customers' requirements. If the interpretation of the requirements is off by just a little, the customer can see the discrepancy and notify the developer right away. Doing this early in the development process saves time, money, and aggravation. It's much easier to make changes early in the development cycle. There are 4 practical classifications of software prototyping models. 1. Rapid prototyping. Consider a scenario where a prototype is frequently required in the software development lifecycle (SDLC) for various purposes, no matter how small the changes in source code. Rapid prototyping is ideal for matching such testing requirements or demonstrating small additions. For this reason, rapid prototyping is mostly used in agile development methodology, where minimal changes are quickly developed and implemented for each sprint. As software development moves from stage to stage, previous prototypes become useless. Therefore, rapid prototyping is also known as throwaway prototyping. where each precedent prototype becomes irrelevant to the current state of development. 2. Evolutionary prototyping. Once the evolutionary prototype is demonstrated, stakeholders can help to define and refine previously unclear requirements. Evolutionary prototyping uses an interactive process for implementing external feedback, identifying new requirements, and confirming compatibility as new requirements are added. In a way, evolutionary prototypes are similar to a minimum viable product or MVP, but instead of starting with basic, minimum features, development begins with only those features that are identified and understood. 3. Incremental prototyping. Incremental prototyping is the only feasible model for enterprise software, because enterprise applications are typically modular and require significant integrations. In this type of prototyping, multiple, smaller prototypes are developed for each feature of the comprehensive software solution. Once all such prototypes are developed, they are combined into a single big prototype that represents the actual software. 4. Extreme prototyping. The primary benefit of this method is that it helps developers catch bugs and issues well before they reach the production stage. As a result, it saves costs that would otherwise require rebuilding the product to solve the issue or to make it functional for the user. The primary benefit of this method is that it helps developers catch bugs and issues well before it reaches the production stage. Software prototyping is a way for software publishers to get a preview of a product they would like to develop before they go to all the trouble to manufacture, advertise, and sell that product. A business or entrepreneur can follow these steps to develop a highly efficient prototype, and these steps are: 1. Define software requirements. In the first step, the entrepreneur is required to define all primary feature requirements of the software. He or she can go into detail about the most important features that are required for the basic functionality of the product. In contrast, details of secondary features such as software security, settings option, and an intuitive interface can be added later. 2. Create the initial interface. Once the software requirements are developed, a simple interface with minimum effort is designed to showcase those features. This is called the initial prototype, which may not be fully functional but aims at resolving key problematic areas with the defined requirements and establishes an interface-like structure. 3. Review the prototype. After setting up the interface, analyze it from various angles. Demonstrate features and added functionality to all stakeholders to confirm the direction of the project stays on track. Also, get your prototype reviewed by test users, who can recommend the missing features and help you ameliorate the prototype. Note that in the case of incremental prototypes, getting test user feedback can be costly and time-consuming, so you may want to pass on getting early adopter feedback on all builds. 4. Improve the prototype. Repeat the aforementioned steps, iterating improvements based on stakeholder and tester feedback until you develop a prototype that accurately demonstrates targeted application functionality. The final prototype should also be sound and capable enough for public demonstrations and the development of the actual product. The prototyping model is a software development model in which a prototype is built, tested, and reworked until an acceptable prototype is achieved. It also creates a base to produce the final system or software. It works best in scenarios where the project's requirements are not known in detail. It is an iterative, trial-and-error method that takes place between the developer and the client. The prototyping model has 6 SDLC phases, and we shall discuss them now. Step 1. Requirements gathering and analysis. A prototyping model starts with requirement analysis. In this phase, the requirements of the system are defined in detail. During the process, the users of the system are interviewed to know what is their expectations from the system. Step 2. Quick design. The second phase is a preliminary design or a quick design. In this stage, a simple design of the system is created. However, it is not a complete design. It gives a brief idea of the system to the user. The quick design helps in developing the prototype. Step 3. Build the prototype. In this phase, an actual prototype is designed based on the information gathered from quick design. It is a small working model of the required system. Step 4. Initial user evaluation. In this stage, the proposed system is presented to the client for an initial evaluation. It helps to find out the strengths and weaknesses of the working model. Comments and suggestions are collected from the customer and provided to the developer. Step 5. Refining prototype. If the user is not happy with the current prototype, you need to refine the prototype according to the user's feedback and suggestions. This phase will not be over until all the requirements specified by the user are met. Once the user is satisfied with the developed prototype, a final system is developed based on the approved final prototype. Step 6. Implement product and maintain. Once the final system is developed based on the final prototype, it is thoroughly tested and deployed to production. The system undergoes routine maintenance to minimize downtime and prevent large-scale failures. If you have enjoyed this video, don't forget to visit our online educational platform at www.eduslides.com by registering for free courses. Guess what? You can as well earn a certificate of completion after completing your course, and you don't have to pay to register. Why not subscribe to our YouTube channel to get more videos by clicking the subscribe button below?